Hello. I hope everybody can hear me. Good afternoon. I hope everybody is doing well. Hello, Yura. So, a few people had issues installing some of the packages, and Yura actually tried to help those people who had some problem. But if you had some problem with the optional packages like GG Animate and GG Force, don't worry about it. Yeah, we won't. They are not that. They're not that important, and we may or may not even reach to that level today. Right? Uh, but if you continue to have problems with installing the packages, just let us know, and I will try to help you. Right. So maybe in a couple of maybe in 1 minute we'll start. Okay, I think we can start. So good afternoon, and again, so today we will be plotting data, and this will be uh, kind of what we aimed for when we started the course, uh, to and get your data in R, to do some kind of analysis on it, and then to plot it, right? uh, so we covered a lot in, I mean, including today in 5 sessions. It's a lot of material, uh, which typically should be done in like a couple of months, or maybe even more, like 2 to 3 months of material, right? So just take it slow, and keep practicing by yourself. Yeah, if things are not very clear, right? Because it's like learning a new language, and anytime you learn a new language, it always takes some time, right? Cool. So um, just the course organization, I think you all know, all the information is on GitHub. And today we will directly jump into ggplot, because we'll look at what we did last week while we are working with ggplot. Yeah, so we'll start with ggplot directly. So what is ggplot? So it is a library for making plots, but it's more than just a graphical library. Yeah. Um, so it not only helps you make plot, but it essentially gives you a grammar as well. And uh, we saw what a grammar means when we were doing dplyr, right? So that was kind of like the grammar of data analysis or coding, and in this case it's the grammar of graphics. And if you uh, I mean, it's because it's from the same guy, so it's also by Hadley Wickham originally, who made this package. So there are a lot of similarities between tidyverse and ggplot, and they work nice with each other. So if you're familiar with tidyverse, and if you're working with this, uh, okay, so I think, just 1 second, Vivian is hearing two voices. Is it the case with others also? Is it something that because are others also hearing two voices, or shall I continue? Uh, can somebody just give me some feedback if others are hearing two voices? Okay. Okay, so then I'll just continue. Yeah. Okay. Cool. Okay. So Vivian, I hope that you can figure it out. Maybe it's something else. Yeah. Cool. Okay. Thank you. So what is the grammar of graphics? So actually, grammar of a graphics is uh, it's originally um a book by a statistician. I mean, graphics plotting your data is a big part of statistics, right? It's visual statistics. Um, Based on this book um, is where a sort of grammar of graphics started to come, and I'll explain what this means. So this is just the same concept as last time. So with the grammar, um, you have a structure, right? So like for in a sentence, when you have different words, you know what the category of the word is, how they're arranged with each other, how they connect to each other, right? So all of these connections, categories, and a structure is given by grammar. Yeah. And this kind of grammar is particularly helpful for graphics also, because there are kind of infinite ways of showing your data, right? So there is not one graph uh, that can show your data. You can show it in multiple thousands of ways, right? And if you want to show your data in different ways, there are two things that you can do. One thing is to plot it in a completely different way, right? So if you want, let's say, if you want to shift from a box plot to, let's say, a histogram or a dot plot, line plot, right? You could just remake the whole plot, right? So that is one thinking behind plotting, right? Just have a different way of for making each and every plot. But what grammar of graphics actually defines is that that is a bit inefficient. And what the grammar does is it breaks down each and every plot into seven underlying, let's say, constructs. Yeah. So there are seven essential elements to each and every graph. And how you mix and match these constructs will allow you to change the graphs, will allow you to change what is being plotted and how it is being plotted, right? And the important thing is that once you have set up one of the construct, you can essentially replace any other layer and get a different kind of graph or get a different kind of plotting. So you don't have to redo the whole thing again and again and again. You can just mix and match things, right? And we'll see how why it becomes very powerful. Okay. So the three things that we will start with today, the three main layers are data. Well, you do need some data, right, to make a plot. Without data, there is no plot, right? Aesthetics. So aesthetics are what is plotted where, right? So what is on the x coordinate, what is on the y coordinate, what is defining the color, what is defining the shape, all of these kind of things. And then geometries. Geometries are the kind of plot that you want. So for example, box plot is a geometry, histogram is another geometry, right? So if you want to move from one type of plot to another, then you keep your data and aesthetics the same, and you just replace your geometry, right? So then changing from one plot to another is as simple as this, right? And we'll come to that. So first thing is we'll start with the data from last time. Yeah. So that way we can also look at how to get the data into R from the last time, and uh, we'll try to plot that data. So we'll be using the same files as the ones from session 4. Yeah. So I hope that you have a folder still, right? And so again, I'll be coding alongside, and you guys can try to code. Um, but I'll be also using a file that I made for reference Yeah, just a minute. So first thing is to make a new R file. So let's make a new R script, right? And once we have made a new R script, we know that we want to read some files, right? Uh, to read some files, we have to know where the files are stored, right? And what is the position of this R file that we have made in respect to those files, because we want to read them. So as Ira had shown last time, you can get the current directory in which you are using getwd, so get working directory. So this thing will tell you which directory you are in. And if you want to set a different directory because you want to go to the folder where your files are, you could either use set wd, then apostrophe, and if you press a tab, it will show all the folders and files in the current directory. Yeah. If you want to go to a subdirectory of the current one, so then you click on this, then press tab again. Yeah. So every time you want to go into a subdirectory one by one, you just keep on selecting a directory, then press tab, then it will show the contents of the subdirectory, so on and on, right? So this is one way. Another way is if you have your R Studio and you have all of these options on top, you can go to session, and this is how I do it, because I mean writing a command is sometimes a bit this is a bit more graphical user interface, right? So you go to session, choose set working directory, then choose directory, and this will pop open a window where you can navigate as you want, just like a normal directory window, and then you can choose the directory which you want to set, right? And just make that the directory that has the files from session 4, so the 2 Excel files and 1 CSV file, right? Yeah. So I hope that everybody is now comfortable with setting the working directory and coming to a point where you can point from R where the files are, right? Because R will not be able to search them without your help. So you have to point it in the correct direction. Yeah. So let's take the experiment with the 2 drugs. Yeah. So I'm just going to call it exp as a variable that is going to read. Yeah. And then I'm going to do read underscore xls. Right. Now I'm going to try to run it, and you will see that it says error. Could not find the function. Right. And the reason it could not find the function is because this command is not part of base R, but it comes in a package. Right? Packages provide you with functions that will help you. So you of course have to call the pack. You have to load the package. So we will load the package read excel, and now this command becomes available to us, and we can also see the arguments. So we'll do path. So if you press tab, it will show you the current directory, and if your files are not in the current directory but in some other directory, first choose the directory, then press tab again, and it will choose uh, it will show you the files within that subdirectory, right? Yeah. And then we'll choose the file experiment2drugs.xls. So we'll try to read this one in. Yeah. And let's see, let's make a glimpse at experiment. And now again, it tells me that there is no function like glimpse. It doesn't really recognize this function, right? And that's because I have not loaded the package that allows me this glimpse that comes with this glimpse function. And I think it is part of the tibble package. Let's load it. Now glimpse is working, right? So you have to first load the package with library, and then you will get all the functions that are coming with that package. Yeah. So you see that there are 3 columns, right? Control, drug 1, and drug 2. And so this is not a tidy format, and it's not a tidy format because all the observations are split in different columns, right? In a tidy format, all the observations have to be in the same column. So we'll make them tidy, and to make them tidy, we will use pivot. If you did the the exercises for session 4, then you might also be familiar with gather function, because that was part of the swirl exercise. So if you want to use gather function here, you are free to use it. Yeah, both pivot.longer and gather will do the same thing, right? And now again, you see, it is going to tell me that I couldn't really find pivot.longer, and that's because it's part of the, I think it's part of the tidyr package, yeah, to functions that will help you make things tidy, right? And also I need this pipe function, which is part of the dplyr package. After this, now we can do, so which of the columns do we want to combine together or make them tidy? Well, everything, right? So we choose everything. Next, what would be the names to, right? So we will say treatment. Okay. So the name of the column where it will go, right? And then what will be the values? The name of the column where the values will go. So all of this together, if we do, then we see that it has put everything together, right? The names of the original names of the columns now actually become part of a single column, and the values within each column now are arranged, are now are combined, not arranged. And it looks a little bit unarranged, first thing, and second thing, if you print everything, then you'll see that there are some missing values, and that's because our original data was asymmetric, so it had different number of values in each column, right? So we want to get rid of both of these things, so we can use the function drop.na, and this will remove all non-existing values, and we can say that I want to arrange for treatment. And once it's done, then your data is tidy, nicely arranged without any missing value. So we will overwrite our original data. And for overwrite, we don't use the pipe, use the assignment operator. So we assign all of this back to the original variable. So back to exp. Right? Now we can do view exp, and you'll see that it's nicely arranged, no missing value, and it's tidy format, right? So I hope that everybody is comfortable until here. They can read the file and make it tidy, at least for this simple instance. There is no linked values. This is the most basic file and the most basic way to make a tidy format, right? So if there is any problem, let me know, right? This is the basic, because now we will start with ggplot. And for ggplot, because we want to use ggplot, we have to first load the library. First load the package. So we'll do library ggplot. And we will start with what we said are the three main basic layers in ggplot. So data, aesthetics, and geometry. And I'll show you how to define each of this. So for ggplot, the first thing is that you first have to define the plot. So you have to first define what these different values will be, and then you save it. And also the ggplot object it's actually an R object, right? So you can actually save it. You can keep adding to it. So I'll show you. So you don't plot things directly, but instead you first initiate a ggplot. So first thing is to initiate a ggplot, and that means we are going to define our data and part of the aesthetics. We don't have to define all the aesthetics. So aesthetics will be what will be on x-axis, y-axis, what will be the shape of the plot, shape of the points, size of the points. We at least have to tell it what is on x and y axis. Yeah. So we initiate a ggplot. So let's say we say p dot to So this will be our ggplot object, and we initiate a ggplot using the command ggplot, right? And then we will define two things: the data and the aesthetics. So as you can imagine, the data is our variable that now contains tidy, our data tidy with two columns, treatment and cells, right? So this is our data. And the aesthetics are defined using mapping. So the way to define the aesthetics is mapping equals AES. And this is always the case with ggplot. Whenever you want to define aesthetics, you have to do mapping equal to AES. That means we are defining the current aesthetics. And in the aesthetics, two basic values are x and y. So what do you want on x-axis? What do you want on y-axis? So we say that on the x-axis, we want treatment. And then on y-axis, we want cells. This is it. This initiates a ggplot object. Now, if you plot it, and plot means just writing the name of the variable and then running it. So we run this. You will see that an empty plot will be plotted. There is no data on it, right? And the reason why there is no data on it is because you are missing the geometry. We haven't yet told ggplot what kind of plot do we need. Do we need a box plot, bar plot, uh, dot plot? What kind of plot do we need? And that is defined by the geometry, by this layer called geometries, right? And as ggplot is a layered plotting, so there are multiple layers. One layer is data, another layer is aesthetics. You can keep on adding more and more layer. So to add the layer of geometry, we just write the name of the ggplot object plus. Plus means add another layer to this plot. And now the layer that we want to add is a geometry. And therefore, as expected, these layers start with geom. Geom means a geometry. So geom underscore. And now you will see that there are many different kind of plots that you can make, right? So we will start with the box plot. So we just say the ggplot object plus add a layer of geometry, which is a box plot. And when you run this, you'll see your first plot. Right? So this is the minimum that you need to make a ggplot. You need your data, of course, because you have to tell it, where to get the information. You have to define your x and y axis, which are part of the aesthetic layer. And aesthetic layers are always defined with mapping equal to AES. This is the way of defining the aesthetic layer. Then you have to define your geometry. And it is layered. Now, this is the advantage of layering. Let's say you want to add points, individual points, onto this plot, right? That means you want to add another geometry, right? So therefore, you just say initial ggplot object plus geometry of box plot plus another geometry. So we'll say geometry underscore points. Let's plot individual points. right? So this is something, I mean, you will have to become familiar with what different geometries are, but essentially each geometry is one kind of plot, right? So once we do that, you will see that individual points are now plotted. And if you think that this doesn't look very good, then you can also use geom.jitter, in which it makes a jitter plot. So a jitter plot is only different because it adds a little bit of noise, random noise on the x-axis, so that points do not look aligned vertically. Yeah. So now you will see that the points are kind of like shifted a little bit on the x-axis. Yeah, it just adds random noise, so that visually you can see the points. And it also helps if your points overlap, because if two points have the same value, then if you do not add jitter, they will be stuck on top of each other. Then you do not really know if it's 2 points or 1 point. So you add this kind of jitter, and this allows you to see all the points, almost all the points. Yeah, because this random noise is added individually to each point, so very low chance that 2 points will uh, fall on each other. Yeah, right. So now we can go further and try to uh, change a few of the attributes, change a few of the things here. So remember that aesthetics controls how the points are plotted. It anytime that you want to change your data presentation based on the data itself, we have to change the aesthetics. Yeah, I hope that made sense. If you want to change the complete plot, then that's not an aesthetic. Aesthetic is when you want to change the parameters of the plot based on the data. So I'll explain what. Let's say if you want to make all the points red in color, right? That means you do not care what the data is. All you care about is that all the points should be color, or red in color. It's not an aesthetic because it doesn't really depend on your data. And you can do that. So if you just want to make all the points into red, so that means it's a property of this geometry. So within this geometry, we want to make everything red. So within this geometry, we just say color equals to red. And now when you change, when you do this, then you see that all the points have become red, right? Irrespective of what their value is, irrespective of which group they belong to, right? And you also see that the box plot did not become red. That's because we defined uh, this parameter inside of the jitter geometry. So it only changed that, right? Now, let's say that we are not interested in seeing everything red in color, but what we are interested in is having all the groups in their own color, right? So if the point belongs to a control group, then it's one color. If it belongs to drug one, another color, and a third color for drug two. So now in this case, the presentation depends on the data, and then it becomes an aesthetic, right? So then we are again wanting to change this within the jitter layer, right? Because we only want to change the color of the points. We don't want to change the color of the bar plot, so we don't change anything anywhere else. But within the jitter plot, we want to change the aesthetics. So if we want to change the aesthetics, we always say mapping equal to AES. And you do not have to give the data again, because anytime you add another layer, all of these layers can look at the initial ggplot object. So they can get their information from the original object. So you do not have to again give it all the information. They will extract it automatically. So we want to we want to color them based on treatment. Yeah? So it has to be mapping equal to AES because it's an aesthetic. It depends on your data. And now you say that change that color the points based on which treatment group they were in, or based on treatment, and treatment is groups, right? So it will become treatment group. Now when you do that, you see that each individual uh, treatment gets its own color, right? And because this color dependent on your data, it's part of the aesthetic layer, and that is why it has to be done like this, right? So if you want to change something globally, of course within a layer, so if you want to change the color of the entire color of a layer, then it's not aesthetic, then you just directly type it. But if you want to get this information from your data, then it has to be part of aesthetic. And once you become familiar with this, then ggplot is super easy. Yeah, this is just the language. So this is the grammar, right? So the grammar is these different layers and how they interact with each other, right? So you can define an aesthetic layer for geometry for your data. So x and y, this aesthetic layer we define for our data, and then this aesthetic layer we have defined for the geometry of jitter, right? Now let's say that I want to make the box plot which is behind a little bit gray, right? So I want to make all the boxes gray in color, irrespective of what data they are representing. So I'll give you 5 seconds to just change it. So just the box plots become gray, irrespective of their presentation, right? So just like we had done for jitter, you go within the layer of box plot or the geometry of box plot and just say color equals to gray. Okay. So now we have our original ggplot object. We have a geometry of box plot, and within this geometry of box plot, we have the parameter that the color of this geometry should be gray. Then we have another geometry of jitter. And within this jitter, we say that the aesthetic for this jitter plots should define the color based on treatment. So Vivian, whenever you want to assign your color based on something in your data, we just do mapping equal to AES, and then color equal to uh, that column or that parameter in your data. So if you are asking how can you assign manually, how can you assign particular colors, because in this case the colors were predefined by ggplot, it is also possible to manually assign particular color. So yeah, like if you want to make this thing red, green, some other color, you can do that. I'll just it's a little bit tricky, so I'll just leave it for you to search, or maybe we can cover it for the next session. Yeah. But the default colors in ggplot, by default it will just assign different colors. So once we run this, right, now all the box plots have become gray in color, right? Now you could do the same thing with box plot. You could also say that, well, I want my box plot to be of the same color as the jitter plots. So I want them to be colored based on treatment. Very simple. We just put this also here. So even for the box plot layer, we say that the aesthetic of color depends on treatment. Yeah. And this changes it. If you want to assign custom colors, I'll make an example for the next session. Yeah. So we can cover it next session. But right now, let's just work with the default colors. Yeah. Right. Right. So this is the basic the basis of ggplot. So these are um, the three things that you need minimum. So you need your data, you need your x and y coordinates, which are part of the aesthetics, and then you need some kind of geometry. And you can uh, you can add multiple geometries, just like you're adding multiple levels. The only thing is the geometry that you add first is also plotted first. So whatever geometry you want to see in the background, you have to write it first. So for example, if we do this in opposite, so first we do the jitter, and then if we do the box plot, so I just uh, change the alignment. So first the ggplot object, then the jitter, then the blocks. Okay. So when you run this, you'll see that the points are behind and the box plot is in front. So it's hiding some of the points. Yeah. So it's just that whichever layer is defined first gets plotted first. So you have to just be careful with what do you want to plot before and then later. Yeah. Also also let's now say that this looks okay, but my points are a little bit too spread, and also they are a little bit too bright. Yeah. So we want to reduce the spread of these jitter points and also to make them a little bit transparent. Now we want to do that for all the points, right? So it's not an aesthetic, it's a global phenomena that you want to do with jitter. So just, I mean, you can always see at different parameters, but alpha is a parameter that controls the transparency. So you can do alpha equals to 0.5. So this means, so you see, alpha equals to 0.5 is outside the aesthetic. And that means that all the points, irrespective of which data you are interested in, will get this property. Now when you run it, you see the points become a little bit dim, right? And now you see in the box plot, there is actually one outlier. This is coming from the box plot, right? And you say that you're not really interested in showing this outlier because it looks like it adds another data point, right? You're already showing the individual data points with the jitter, so you're not really interested in showing this, right? So that would mean that you want to modify your box plot geometry. So we have to go into the geometry of box plot. And if you go and see here in the outlier, so it's an outlier, it actually tells you hiding the outliers can be achieved by setting outlier.shape equal to NA. So that is what we set. And again, this is outside the mapping aesthetic, because this is something that you want to happen in all for all the box plots. I mean, in here there is only one outlier in one treatment, but anyway, we want all the outliers to be hidden, right? So within the geometry of box plot and outside of the aesthetics, because it doesn't really depend on your data, we specify that for all box plots, remove the outlier. Okay. Now when you run this, you'll see that the outlier has gone and you only have your box plot along with your points. Okay. Yes, okay. So that is, so if you are happy with this plot, then you can again save it into a new object. So let's say p.final. So we'll do it like this, p.final, right? So now what you have done is you have taken your initialized ggplot object, added these two geometries, added some parameter for each geometry, And then all of this is saved. So saving is done by assignment into a new object. So now this thing will have all of this information saved into it. So you don't have to type this again and again. And then whenever you call or run the final object, the plot is remade. And it's exactly remade just like before. Yeah. So now p.final has information on your data, the original mapping, the geometries, and the different parameters for each and every geometry. Yeah. Now let's say you want to continue editing it. And this is one big advantage of ggplot as compared to base R, because in base R or in other kind of plotting objects, once you plot something, it's very difficult to change it, to edit it, unless and until you want to go back. So you actually really have to go back to the original uh, whatever code you wrote, and then you have to change things. But with ggplot, you can keep on adding layers. So now we will look at another layer. So let's say you do not like this gray box here, yeah, which is behind all the plots. You don't like it. So this is part of the theme. So theme essentially controls the the overall look and theme of the plot. The overall, yeah. So how the plot looks, how things are. Not really something to do with data or with geometry, but just overall how the plots are looking. So now we will change the theme. So we take this final object that has all the information about data mapping and geometries and add another layer of theme. So all the theme layers are starting with theme, and we will choose theme underscore classic. So this object plus theme underscore classic. Now when you run this, it has changed the theme, right? There are other parameters. So theme underscore classic, it's a predefined theme. So you do not have to change the parameters. So it just comes. So it will change the look, but you can also define certain aspects of the theme. So for example, you do not like that your legends are on the right side of your plot. You want them to be, let's say, on the top. Yeah. This is another part of the theme, right? Because it has nothing to do with your data. It has nothing to do with the type of data, right? I mean, it doesn't matter if you made a box plot or a bar plot or just a dot plot. The location of the jitter has no relationship to it. Sorry, the location of the legend has no relationship to it. So irrespective of the plot, uh, legend will be there. And if you want to change the position of the legend, then it's a theme parameter, right? So we will say theme and then legend dot position. Okay. And in this, you can use top, bottom, left, or right to tell where the legend will be. So we say theme legend dot position equal to top, and you'll see that the legend goes up. Right. So it wouldn't have mattered what kind of plot it was. The legend would have moved, right? So it's not, the position of the legend doesn't depend on what kind of plot you make, and that's why it's part of the theme layer, right? And similarly, you can keep adding, also changing the font or the size of axis. So if you want to change the size of the font of treatment or control, that is also part of the theme. Yeah. So this is good. And now you want to add some statistics, right? Because this is okay, this is the plot, but we have no statistics here. So statistics is of course now part of the statistics layer. Yeah, because this is another layer here. So we have covered the data layer, aesthetic, geometry, and theme, and now we'll go to the statistics layer. So to make statistics, we'll need another package. It's called ggplot. So this was something we have to add. So we'll call it, we'll say library ggplot. And also this the p final with all the theme changes, we can also save it. We can just overwrite p dot final, right? Because anytime you make a change, you add some new layer, uh, either always you have to keep on calling with the new layer, or you can always save it into another object and then it will remember all that you have done. And just in case that you are interested in looking at what you had done with the ggplot object, you can write the name of the object, so p dot final and then dollar. And if you look at layers, then actually it will tell you all uh, the different layers, or all the different transformations you had done to this object. So how did you start? What was the first thing, second thing, third thing? Yeah. So it will tell you, so you can actually go back and look at all of the things that were added. Yeah. Most of the things. Here it is not showing the changes in themes, but it's showing what the different geometry. So it's showing the box plot geometry and the jitter geometry. Right? So now let us add some stats, right? So as you can imagine, to add a stat layer, you have to start with stat. So the stat layers are starting with statistics, right? Statistic layers are starting with stat, stat underscore, and we'll say compare underscore means. And because it is 3 groups, so we want ANOVA. So we'll say method equal to ANOVA. We can also have a look at the help page for stat and stat compare means. So once we say help page, then it will show you all the parameters. We don't need to define the mapping because we have already defined it, and it will take this mapping information from the previous that we had made. We don't need to define the data because the ggplot has this object. We need to define the method. Yeah, so which of the method is needed, and here it will tell you what are the different methods. I think it tells here, or yeah, one method is t-test, and more than 2 groups, the method is ANOVA. Yeah. So let's do this. So we have our ggplot object with all the layers, including theme, and we add another layer of stats onto it. And once we do that, you'll see that the p-value for ANOVA has started to come. I have zoomed into my image, so that's why there is a bit of overlap. But if you're not happy about where it has put the p-value, you could always say there is a parameter which is label.y and label.x. So you can manually define where the stats will go, the position where the stats will go. So we can say label.y equal to 18, right? Because the plot is going until 16. So if we just do that, it will move it up, and it will automatically expand the plot as well. Right? And now the ANOVA p-value has increased. Right? So now we have made a plot that has 5 different layers. It has the data layer, it has the aesthetic layer, that is what is on the x-axis, what is on the y-axis. It has 2 kinds of geometries, and for each geometry it has its own aesthetics, right? Some of which that depends on data. So the color depends on the data, but it also has some parameters which don't depend on data, like the transparency, right? And then a theme has been changed and the statistics has been added, right? So these are now 5 different layers that we have in the plot. Yeah, and this is how ggplot is always working. You go layer by layer and you keep on defining what all you need to add. And for most of the things, uh, it will make a good plot. So it will be able to put things in the correct place. But sometimes if it's not able to put things in the correct place, then you can manually assign things, right? Now this is okay, but this is only ANOVA. But we also want to know which of the uh, groups are different from each other, right? So we will add another layer of stat, right? Because that would be another statistical comparison. So we will again say stat compare means. Now our method will be t-test. And the reference group. So which of the group will it compare to? So there are 2 ways of doing it. First, we will do it by putting a reference group, and then without putting a reference group. But right now we can say a reference group is equal to control. So what it will do is it will do t-test, comparing each group to control, and if they are significant, it will write this value of significance. So you'll see that it puts that value, but it's not looking very good. It's kind of looking a little bit messy, right? Because it writes the full thing, t-test p equal to this. And most of the time we don't really want this. So what you can do is you can just say label. I'll just check it is label. Yeah. If you just say label equal to p dot significance, you can also see this in the help page. So let's go to the help page and see. So if you look at label, then it says that character string specifying label type. Allowed values are p dot significant, shows the significance level, and p dot format shows the formatted p value. So we want p dot significance. Yes, we can. Yes. So just do this. So then you will start to get what we are more familiar with are the stars or the asterisks. Yeah. So these are the asterisks. So non-significant will mean p greater than 0.05, single, double, triple, and 4 times. Yeah. And this is what I normally use. So I'm normally not really typing putting the p-value. Just for ANOVA is fine. But even for ANOVA, you could also say label equal to p dot significance, where it puts the asterisk. So Ali, you are getting, well, because well, for each statistics, they are not part of any mapping. So they are just stat underscore compare underscore means and then method. So there is no mapping here. So if you also do not want the p-value for ANOVA to be like this, if you are not happy, then you can also say label equal to p dot significance. I am actually not really sure if how to just put 3 decimal formats, Vivian. I will look it up. Yeah, I'm not really sure if how to do that. I do know that you can just change it from the original number to asterisk, but I do not know how to control the number of decimals. Yeah. But here you can do it. Doesn't look good because it doesn't really say anything. So for ANOVA, we will leave it like this. And for the others, we have this. One thing that I also normally do is make a plot like this and make one plot without the asterisk, so that I have the original p-value as a number, but this is more for publication quality. Yeah, because it's also good to have a number, like what is the exact number, because sometimes in legends you have to write the exact number, right? Yeah. So this would be the way to add statistics, but here we have done it's not really pairwise, because as you can see, drug 1 and drug 2 have not been compared to each other. Drug 1 has been compared to control, and drug 2 has been compared to control as well, but there is no comparison between drug 1 and drug 2. So if we want to have these kind of comparisons, it's a little bit tedious, because you actually have to define all the comparisons that you want. So let's make a new vector where we will tell what all comparisons we want, and it has to be a list. So a list is a collection of vectors, right? So like using C, you collect scalars, you collect values to combine them into a single vector, and with list you can combine different vectors, right? So we have to give it all the pairwise vectors that it should make the comparison for. So we have to tell it make a comparison for control and drug 1, drug 1 and drug 2, and control and drug 2. Yeah. So unfortunately, this has to be a bit tedious, but you just say list, then as a vector, what all pairwise comparisons you need, and for each after each pairwise comparison, separated by a comma. I hope, Ali, that you could figure it out. If not, so we make a list, which is a collection of vectors, and each vector is the pairwise comparison that we need. If you are really interested, then I will put this in the R file. You can use a function called combine n, which will make these kind of pairwise comparison. It will automate it for you, but we won't go into that. Yeah. So if for such low groups, you can just write it down. It's easier to write it down. Right? So once we do this, then we go back. We'll take everything. Yeah, so this was our ggplot object that did not have any statistics. Then we added ANOVA to it, and then we added pairwise comparison. So here, instead of a reference group, we just say comparisons equal to the list that we made, equal to my underscore comparisons. Yeah. And once you do that, then you will see that it adds these kind of square brackets, right? It doesn't look good because our ANOVA is in the way. So we'll move our ANOVA a little bit up. Right? And the other thing also is that it's going to put these pairwise comparisons in a way that we assigned it. So the first bracket to be drawn will be control drug 1, and then so on and so forth. But sometimes it's better to have the biggest one on top, right? So we'll just move it around. So the first one will be control drug 1, then right? So I just moved drug 1, drug 2 above control drug 2. So that means it will first make this bracket, then this comparison, and then this comparison bracket. Yeah. So one by one. Right? And now it makes it really nice and clean. Right? So you have your ANOVA value, you have all the pairwise comparisons that you want, and the significance level for all pairwise comparisons. Okay. Yeah. So this is now the statistical layer, the layer that allows you to do some stats and also print them on your plots. Right? And now if you add another plot, or if you change any parameter, it doesn't really matter, because changing of a layer will not impact other things. So for example, let's say, just a theoretical example, if I want to add a violin plot over this thing now, right? I think I want to add this. So I just add plus another geometry, geom underscore violin. And then when we run this, it's just gonna add a violin plot. It looks, I mean, of course, we will not do that. It looks bad and ugly, but it just to make a point that when you add another layer or add another property to the plots, you don't need to change everything else. It's all constructed for you. So all the layers are independent. So adding another layer doesn't impact the other ones. Right. Only thing is that the order of the layers have to be in the way you want them. Right. But we can also make this uh, highly dim, let's say. So let's say we make it alpha equal to 0.2. So we just make the violin plot very, very dim. Let's see if it does. Right. So it just, yeah. I mean, it's not a good looking plot, but just to make the point that you can keep adding as many layers as you want. It's uh, there is no end to it, right? You can modify anything. Uh, so your plot is never really it's dynamic, yeah, because it has a grammar and it has a structure. So when you change the structure, when you change parts of the structure, other parts are not completely destroyed. Yeah, that remains how it is. Right? Now, if this is the final plot that you are very happy with, and one thing that I forgot, if you are not happy with the size of the asterisk and you want to increase or decrease it, the parameter is cex. So this parameter will change the size of the asterisk. So if you are very happy with the, sorry, I assigned it to p. If I just run it, it didn't really change much. I thought that it was, yeah. Okay, I guess it works more for this. Let's just check. I just want to check once. Yeah. Okay, so for some reason, this parameter doesn't really work with these kind of comparisons. When you have a reference group, then you can use this parameter. Okay. Yeah. So if you have a reference group and you want to change the size of the asterisk, then cex will do the job for you. So this is going to change the size of the asterisk. I'm not really sure. I thought that it would work for both of the comparisons, but apparently for this kind of comparison, it doesn't work. Okay. So this were the main 5 layers. There is one more layer that we want to cover, and that is the facet layer. Uh, and for that, we will go to the other data set in which there is linked data. Sorry, before we go there is one last thing to mention. So once you have made your plot and you see your plot and it's nice and you're happy with it, you can save the plot using the command ggSave. So this will save the last plot that was generated, either that, or you could specify the ggplot object which you want to save. If you do not specify it, then it will just save the last plot that was plotted in R. So if you just say gg save file equal to, let's say, my plot dot png. So you just have to specify which file format you want. If you specify .png, then it will save as PNG or JPEG, then JPG or PDF. Yeah. So whatever you specify it as dot, it will save it like this. So you don't have to specify anything. If you are interested in changing the width and the height, then that you can change here. You can also change the resolution. All of these things can be saved. It's also possible to save your plot as an SVG. So if you save things as an SVG, you can actually open them in Illustrator or Inkscape. So because it's a vector format, and there you can then change each and every element of your plot. So you can move things around, you can change the size and everything. Only thing is that saving it as in SVG requires another library. So if you do not have it installed, then this will give an error. I think it requires a library called SVG Lite. SVG, yeah, it requires this kind of library. Yeah. But then you can save your plot as an SVG also, and then open up an Illustrator, change whatever you want to do, then save it as a PNG or JPEG. Yeah. Or another vector is also PDF. If you do like this, then it will save it as a PDF, right? So ggsave will allow you to save whatever was last plotted. So you don't have to plot it again. Right? So now let us go to the other data set, linked data set, and there we will have the example of how can we use facet. Right? So we are going to load that data set and put it into a variable experiment. So we'll read it. Right? You have to know where the file is. And every time that you want to go inside a folder, select the folder, then press tab again. It will show all the files inside that folder. Right? So then we go for experiment with features. Right? And we get this one. So in this file, we have linked data. 3 columns belong to control, 3 columns belong to a drug, and 1 column specifies the day, which belongs to both for control and drug. Right? So we want to make it into tidy. So we will again use the pivot dot longer. And in this case, we will say columns equal to minus day. So only the day column is already in tidy format, right? Because all the values related to the observation day are already in one column. So we do not have to do anything. We only need to combine the 2 columns cells, then age and gender. Right? So we say do not do anything with day, just keep it as it is. And then we will say names too. So in this case, we will use a predefined structure of the column names to make them combine. Right? So we will say that our column names are in the format in which the first part of the column name is a value, and the second part of column name should go into a new column called treatment, right? Because if you look at this data, then the first part of the column name tells you what kind of value does the column have, right? So this column has values related to cell, right? So the first part of this name has cells, the second part has age, the third part has for this column the first part has age, and for this column the first part has gender, right? So the values inside the column belong to this parameter in the name, right? And the second part of the column name should go into a new column. Yeah, so this will become names too. And we also have to tell it that these parameters are separated, in this case by an underscore. Okay. So when we do this, you'll see that it has made it tidy. So it made a new column called treatment, which contains what was the second part of the column name, and then it has combined cells, age, and gender together. Right? It has some missing values. That's because the data was asymmetric, and the treatment is shuffled. Right? So we will take care of both of these. So we just say drop underscore na to remove all the missing values, and then arrange treatment. And this we save using the assignment operator back into the same data set. And then if we say experiment, now you see that it's tidy, there is no missing value, and it's well arranged. Right. So now let us plot cells in relationship with treatment, make a ggplot, and which is colored based on treatment. Yeah. So let's try to do that. If you want to do it yourself, then you can pause the video to make this ggplot yourself. Yeah. Or just to make it along with me. So we'll first have to assign, initiate the ggplot object, right? So first we initiate it. So we'll say p dot experiment. So plot dot experiment, yeah. And to initiate a ggplot object, we use the command ggplot. We have to tell it where to get the data from. So the data it gets from experiment. And we also can at least tell it what will be on the x and y axis. This is the aesthetic. So mapping equal to AES, x equal to treatment, and y equal to cells. And this initiates our ggplot object. If you try to plot it, it will not plot anything, right? Because we have not assigned a geometry to it. What kind of geometry do we want? What kind of plot do we want? We say box plot, and it will make a box plot for us, right? Let's also add a jitter plot. It will make the jitter plot, right? So now let us have some interesting plots. Now let's say that this is a plot. Okay, that's fine. But now you want to color the individual dots in a jitter, not based on treatment, but based on the gender of that individual point. So let's say if this point was a male, then it should be some color, and if it was a female, then it should be some other color, right? So you want to assign colors to individual dots based on a parameter in your data, right? And this you only want to do for the jitter. Yeah, that means, of course, we have to change something within the jitter plot because this is where we want the change to happen. And because this change depends on your data, it's an aesthetic feature, right? It has to change the aesthetics of this geometry. So to change the aesthetics, we'll do mapping equal to AES, and we say color, right? Because you want to change the color. So color equals to gender. Now notice that we did not provide it any data. We didn't have to, and that's because this layer sits on top of the previous layer, which has all the information about data. Right? So after initiation of the ggplot object, any added layer can always refer back to the original data where it was made from. So you don't have to provide it, it will look it up. And if we do this, now you see what it has done is it has changed the colors based on the gender, right? And this is the big advantage of using tidy data, because all the data is linked to each other, different parameters are linked to each other. So this allows you to shift from one parameter to another and to link these with each other very, very quickly, right? And this is also an advantage of having a structure or a grammar in plotting, right? So now let us say that this is okay, but I also want to change the shape of these points based on the day that the sample was collected. Yeah. So the color is based on gender and the shape is based on day of collection, right? So again, we want to change something that is related to the jitter geometry. We are only interested in changing the points, and this change will be part of the aesthetic feature because uh, it depends on the data. It's not a universal thing. And to change the shape, you just have to say shape. So because the shape, we want it to depend on the day, right? So now you see, it has now your points, the mapping on the X and the Y axis depends on treatment and cells. The color depends on gender and the shape depends on day. Yeah, I hope this is clear to everyone. Yeah. Um, because individual points, the parameter for plotting individual points, it depends on the data, so it's part of the aesthetic. And now you say, well, these points are a bit too small. They are okay, but they are not really visible. So I want to increase the size of all the points. Now, because you want to increase the size of all the points, it's irrespective of the data. So it's not a mapping aesthetic, right? It's a global feature. We have to specify it outside of the mapping parameter, and we just say size. Let's say 5. Right? Okay, it made them too big. We can do maybe 3. Okay, still a bit too big. Yeah, 1.5, let's say. Okay, not really that helpful. Just have to keep trying until you find something. Okay, this is fine. They increase a little bit, right? But you see that all the points increased in size because it was not a mapping parameter, right? Let's also make the box plot a little bit dim. So we can say color equals to gray. And also let's change the theme. So we'll say, we'll make it a classic theme. Yeah. Let's run all of these changes. And here we get the plot, right? Also, if you are not very happy with your legends being there, let's say theme, right? Because legend position is part of the theme. Theme legend dot position equal to, let's make it bottom. Right? So now everything goes here. Yeah. Now we will look at facet, the last layer that we are interested in. So facet. So what is a facet? One second. Yeah. I'm not really sure why this thing is coming in the middle. Yeah, I think now it should be fine. So a facet means to look at the data from one side. So if you have a cube, then it has 6 different ways you can look at it, right? So it has 6 different facets. So facet is like different faces, right? So this is what it means by facet. And normally a facet in ggplot is defined by a group, right? So let's try to do that. So first I will save this to p.final. So this plot, so that we don't have to keep typing and writing this thing again, right? So now the p.final is this whole plot that we have here. Yeah. Now let us add a facet to it. And what facet will do is it will split your plot based on some kind of grouping. Yeah. And so we can make it facet.grid. And what this tells ggplot is that split the plots and put them in a grid, put individual plots in a grid. And we will split the plot based on, let's say, day, or based on gender. Yeah. So if it has to be based on gender, then this formula, the tilde, so facet.grid based on gender. And when you do that, what you will get is you will get 2 plots, not one. Now you have 2 different plots. The plot on the left has all the values only related to female, so F, so one grouping of gender, and all the plot on the right have all the data points related to male, right? So ggplot split it based on the different things. Now let's do this. Let's put the color based on age and split it based on gender, right? Because here the gender is getting repeated, right? So we have split the plot based on gender, so we don't need to color it, right? So let's color them based on age, right? So the only thing to change is this aesthetic parameter, which now was color equal to gender, and now we can make it age, right? Now let us just run it again. Yeah. So now you will see that because age was a continuous parameter, right? It's not discrete, so it's a continuous parameter. So that's why it made it into a heat plot, also a gradient, right? And so whichever points have light color, they are higher in age. Whichever points are darker in color are lower in age. And now the plots are split based on male and female. And the size, the shape of individual points are based on day. Yeah. I hope this is clear. Yeah, how the facets are working and how individual characteristics of plotting can be managed. And once you understand this, then you can do the same for any kind of plot. I mean, it's kind of similar, right? So the kind of plot doesn't matter. Yeah. If you want, you can also change the color of the box plot based on treatment, right? So then you will only have to put within the geometry of box plot mapping equal to AES, color equal to treatment, right? Let's try to do that. So within the geometry of box plot, so we want to change the color of the box plot based on the treatment, right? So we can go into this geometry and say mapping equal to AES, color equal to treatment, right? Uh, Sorry. Wait, no, it should work. Why does this thing not work? Is it? Okay, for some reason, color is not working, but fill was. But that is a little bit weird. It should be able to do it. Yeah. And if you want to make the box plots a little bit dimmer, you can always make it alpha equal to 0.5. I mean, this is just a theoretical example. I mean, it's too much data, I think, to be shown like this. It's a very confusing plot, but it just shows you the power of ggplot on how you can manipulate the data and how it can be changed. So for some reason, the color equal to treatment was not working, but fill was. So fill would mean just fill the boxes. Yeah. I guess it had one aesthetic for jitter and the same aesthetic for box plot. It sort of collided with each other, but should not have. Anyway, so this kind of shows at least 6 different layers, and which are the most important 6 different layer. Maybe facet is a layer that normally you don't really need, but it's a good layer to know about. But essentially you initialize your ggplot object with your data and at least the basic mappings. So the basic x and y axis, what will be on the x axis, what will be on the y axis. Then you start defining each of your geometry, and within the geometry you can define more aesthetics, how your points should be plotted. If it is based on your data, then it has to be part of the aesthetics. If it's not based on your data, if it's universal, then it's just you directly define it, right? And then if you want to change something related to theme, then you can change these things. Yeah. And if you want to split your data, then you can do this. And of course, to this final thing, we can add our stats. Let's say stat compare mean. Right? We don't. We only need to specify the method. So our method is t.test, and we will say label equal to. Let me go to the help page because I keep forgetting it. P.significance. Right? So we add one more layer to it. Right? And now you will see that it actually made, okay, we can also define the reference.group equals to control. And the most important thing what you will see is that it actually made a statistical comparison for each group individually. So you see it puts 4 stars for the female group and 3 stars for the male group. Right? So for each facet that it plots, it does individual statistical comparison. That's because it understands all the underlying layers that are there. Yeah. So you didn't have to do individual statistics for a male and female group. It does it for you and then plots it on the correct place. Right. It's not. I would. One thing that I would advise you is that ggplot does allow you to make these kind of things. But if you do have this data, it's better to make 3 or 4 plots, or at least 2 plots, rather than putting so much information in a plot. It's sometimes not good to put too much information. It's not very. It's very difficult to read such plots, right? But anyway, I mean, if you are interested in doing it, then at least you know how to do it, right? So this is for this made up data. This was a random data, and now we will go and look into some real world data. So um, how to analyze some real world data set, and then how to plot it. So we'll look at the coronavirus data set, which is updated, which is I think collected from John Hopkins, and then there is a person who updates it regularly for R and puts it onto GitHub. I did not update it for I think the last 2 or 3 days, but it has enough data. So that data comes with the library coronavirus. Yeah. And then when you do this, you get a plot, you get an object called coronavirus, which is the data. So we can make a glimpse onto this. So this is a real world data, and it has not been manipulated in any way. It's a big data set, so it has 61,000 rows and 7 different parameters or 7 different observations, right? And I mean, until now we were working with things that we could easily see full, like 20 different rows, but now this is pretty big data set, right? So of course, first thing to do is to just look at the data and get an idea of what different observations are, right? So it has information on the country, right? So which would be, I'm guessing, different countries. And then within each countries, it also sometimes has information on the province. Then the latitude and longitude, right? Date. So as you can see, at least for the first 2 dates, it's every day. So yeah, information about every day, one at a time. Then the cases. So how many cases were detected in that country on that day? And what are the type of cases? So is it confirmed? Right. So let's try to dig a bit deeper into this data set. So let's make a table for coronavirus countries. Yeah. So when we make a table, we will see how many different countries there are and how many observations there are per country. Right. So it seems like for most of the countries there are 237 observations, and the countries are named, right? So you can see different names of the countries. You can see how uh, individual countries are located in this data set, and most of them, it seems like all of them have 237 observations, right? Next, I think we should also look at some other things like cases. Well, cases are just numbers, it seems, but type. It seems that it has 3 types of cases. So it has information on confirmed, it has information on death, and then it has information on recovered. Yeah. So let us view the data set a little bit to understand really how this thing is structured by view. So it seems that you have a country, you have a date, and then you have the number of cases on that date which were confirmed, right? And this keeps on going one day at a time. So it's updated daily, right? So on the day that one confirmed case arised, it says 1, right? So then on this day there were 3 confirmed cases, so 3 is added, right? So it seems like it is the number of confirmed cases for that day and not the sum of confirmed cases in that country, because otherwise if the first case arrived here, it should also be present on the next day, right? It wouldn't really be cured within one day, right? So it's the number of confirmed cases per day uh, recorded in that country. Yeah, and this is happening for each and every country. So the date is continuing, right? So let's say we want to plot the total number of confirmed cases in a specific country. Yeah, so that's going to be our goal, to plot the total number of confirmed cases, the total number, yeah, not the number recorded on that day, for particular countries. And if you want to do the data manipulation by yourself, to make a data frame that will allow you to do that, uh, just pause the video and make the manipulations. Another thing is that the data is already tidy. So that is one thing that you do not have to worry about. Yes, all observations are in their single column. So it's tidy data set. There is nothing that you have to do to make it tidy. Yeah, so that's a big advantage. You can directly start with dplyr to manipulate it. Okay. So as we are only interested in the confirmed cases, we are not interested in the observations which are related to death and recovery, right? So the first thing is that we will remove all of this information because we are not really interested in plotting it. So what we want to do is we want to remove all the rows for which the type of observation is not confirmed. So for which the type of observation is either death or recovery, right? So that means we want to remove them. So we say filter, right? Filter, only keep type which is confirmed. Remove everything else. We are only interested in the confirmed cases, so we only filter that. Right? So once we do that, we will get our whole data set back. But this time, if we make a table on type, what we will have to do is to save this data set. So we'll overwrite it, and then we will make a table on type. So you see all the other values have been removed. Yeah, I hope this is something from the last two sessions, right? So we wanted to remove all the observations which were not which were not giving us the information about confirmed cases. Okay. And now we are interested in the total number of confirmed cases, right? But our data set has confirmed cases for an individual day. So it doesn't really have a total number that is updated daily. It's on that day how many cases, how many confirmed cases were present, right? So we want to make a cumulative sum, right? So cumulative sum means that if you have a series of number, let's say 1, 2, 3, then you want to keep adding the number from the previous day, and you want to keep accumulating it. So that's cumulative, right? And there is a function in R called cumulative sum, CUMSUM, yeah, which will allow you to do that. It makes cumulative sum. So for example, let's say if we take the number 1 to 10 and we make the cumulative sum of this number 1 to 10, then you see what you get, 1. Then on the second place is the sum of 2 plus 1, so 3. Then it's 3 plus 2 plus 1, so 6. Then it's 4 plus 3 plus 2 plus 1, 10, and so on and so on. So cumulative sum is just it takes a position and adds up everything that's before it, right? So if we do this operation on cases, on the daily number of cases, right? So we will be able to get the total number of cases until that day, right? So we want to make a cumulative sum. So let's do that. So we take coronavirus, right? So first thing is, we of course we want to do that, but we don't want to do it for everything because that's going to be useless. We want to do it country by country. So we want the total cases for every country, right? So first we want to make a groupings on country, right? And then we want to make a cumulative sum on the cases. So because we want to make a manipulation and add another information, so we want to mutate the data, because mutate would mean to add new information. So let's say total cases equals to come of the name of the column was cases, right? So what it tells, what dplyr will do is it will take your data, split it based on individual countries, then add a new column which will be the cumulative sum of cases, right? And that would give you the total number of cases that have occurred until that date in that country. Yeah, I hope that this is making sense. Yeah. And of course, we will save it again onto the same data set. Now let us view. This new thing. Now you see a new column has been added, which says total cases. Let's see if it did what we wanted it to do. So the first case was seen on 24th of February in Afghanistan. So on the next day also it remains as 1, right? Because the total number of cases in that country from this day forward has been 1. Now, when a new case of 3 was seen, then the total cases becomes 4, right? It added up. Then another one, so it became 5, then 7, right? So it made the cumulative sum. Did it do it country by country? Let's see. So in Afghanistan, on 9th of April, there were 484 cases. Then when we go to Albania, it again goes back to 0 because it's going to start the counting again, right? And let's see if it did the same for Albania. Okay. So 2 cases, the first 2 cases on 9th of March and then 8 on the next day. So it made the cumulative sum 2, then 10, 12, 23, right? So now we have our parameter that we wanted to plot, right? So now we can actually do the plotting. Before we do the plotting, there are a lot of countries, so we can choose a few countries. Yeah. So let's say we say country dot select. So we can just select a few countries. So let's say we want to do it for India and for, let's say, US. So I will have to see how they are naming the countries. So US is named as US. Okay. So let's plot these 2 countries, right? You're free to choose any other. Just check that the name is correct. And you can also choose more than 2. So it's not necessary to restrict. Just the more countries you choose, the more time ggplot will take. So 3 to 5 is, I think, a good number. Let's also do Singapore because there they were the they control the curve very nicely. And if you're interested in South Korea, then I think it's written as Korea, comma South. Only if you want to see how their curve was. I think it's not South Korea, but it's Korea, comma South in this data set. Where is K? IJK. Yeah, it's Korea, comma South. Yeah. So these are the countries that we will select. So we will again filter our data set based on these countries. So we will say yes, then filter, and then we will say countries comma region. So this is something that we had not covered before. So if you have a vector, and if you want to only keep information that's present in another vector individually, so it's not like you're not comparing the two vectors to each other, but you want to only keep that information um, which is either India or US or Singapore, right? So then this function allows you to do that, percentage in percentage. What it means is that it will look at this first vector, and then it will look at the second one, and if a value is one of these values is present here, it will give true. So this logical operation will be true if the value is either India or US or Singapore. Yeah. So it will do three comparisons. First, or depending on how many elements you have, it will do individual comparisons. So even if it is true for one, it becomes true. Yeah, I think this is the way to do it, right? Yeah, yeah. So we will say country.select, right? So what it will do is it will look at the name of the country or region, and if that name is present in this vector, so if it is either India or US or Singapore, it will keep them. Yeah. And now we can say corona dot selected. We just save it into a new variable. Yeah. So now it has information on only these three countries. And anytime that you want to change, just change the number of countries here, run this command again, and you'll get a new subset. So finally, we are ready for plotting. So if we want to plot, we specify, we initiate the ggplot object. So we initiate it with the command ggplot. Then we say data equal to our selected countries, equal to the data that has information on the selected countries. Then we say mapping. What kind of things do you need on the x-axis and y-axis? And it's part of the aesthetic. On the x-axis, we want date, right? Is the column date, yeah, date. And then on the y-axis, we want total cases. Right? So this will initiate the ggplot object. If you try to print it, it will print nothing. Because we have not yet specified the geometry. And in this case, let's make the geometry as a line. So it will just connect the individual points, right? And within this geometry, we want the lines to be colored based on the country, right? Because for each country, we want a separate colored line. So because that information is an aesthetic value, so we again have to say mapping equals to AES, color equal to country dot region. Right? Now let's plot it. And here we see that it has plotted the three countries. Because of US, it seems the other ones are a bit not really shown. So let's make it log 10. So we can just go here. So instead of saying y equal to total cases, we can say log 10 of the total cases. And now it is at the log of 10. Right? So you can see that initially Singapore did actually flatten the curve. The rise was much lower, but it has still since been coming back, at least the rate of change. Yeah. So I hope that you have an idea of how to look at real world data, how to do some kind of manipulation to bring it in a place where you are happy with what you want to plot, and then get it to plot. Right. Now, of course, if you change the name of country here, it will change, right? So if you also want to see individual points, then you can add another geometry. So a geometry of point, right, which plots individual points instead of connecting them with a line. And again, we will keep the same aesthetic. And it has made them individual line. Now the thing is that for each of the geometry, you always want to specify the color based on country or region, right? This is so this doesn't really change, right, based on the geometry. So this is something that you want to do for all the plots, for all the geometries. So you can even specify it at the top here, so that for each layer it uses the same aesthetic, so you don't have to specify it again and again. So here itself, when you initiate the ggplot, you could say x equal to date, so x and y. Along with it, you could also just specify color equals to country dot region. What this means is that everything that is plotted with this ggplot object will have its color based on this information. So you don't have to keep on specifying it again and again for individual geometries. Yeah. So you can also put such information in the initial initiation object itself. Yeah. If you know that this is exactly what you want for all future purposes. So then we can remove these things. We'll do exactly the same, because in this case, our original object has this color defined. Yeah. Right. Let me just check if there was anything further to if there is any problem or things that is not clear, then just type, because I think we have like 10 minutes, so I can either repeat it or go to the bonus things. But I think few people had problem in installing the bonus thing, so we can also skip it. But if there is some other problem in this thing, just let me know. Yeah. Okay, so I'll just continue. So these are the two additional libraries that we asked you to install, but it was not really necessary. Yeah. So if you just want, you can just stick around for 10 more minutes and see what these libraries can do. Yeah. So the first library is ggAnimate. So it allows you to make movies out of your plots. So it's very, very simple. So we first call the library ggAnimate, and then you only have to specify. So we can just see question mark ggAnimate library or package. And what it allows you to do is to make your plot dynamic. So it allows you to look at the transitions, not just look at the transition, but make them into an animation. And this is defined by the function transition $states. Yeah. So the first transition, let's say we want to see, is that we want to see how these points are moving by date, right? So the function for that is transition underscore reveal. So that means reveal my plot in a transition manner. So animate this kind of thing. So you reveal a certain data point, and this reveal, do it on some parameter. So if we specify date, that will mean that reveal the data by date one by one. Yeah, so don't show everything at one point, but reveal it by date. And once you run it, if everything is installed properly, then it will make the video. It will take a minute to make the video. Yeah. And as you can see, this was just added as another layer. So this transition is just a new layer. So you don't have to change your plot anything. This is an additional layer. It's not one of the main basic 6 layers or 7 layers of ggplot, but it's an additional parameter. It takes a bit of time depending on how much data points you have and all of that. And also, once it makes the animation, you can save it as a GIF or AVI. So you can put it in any PowerPoint. Right. So the plot size is a little bit big. So, but here you will see how the GG animate is working. Right. So we just told it to reveal the transitions based on date. So it is going to make the plot, but is going to keep on adding points one by one based on individual dates. Right. Then the other additional feature, which I think is pretty useful, is part of the package ggforce. And ggforce is a package which is testing new graphic designs in ggplot. So the hope is that once they become stable and once they are nicely they are useful to the community, they will actually become part of ggplot. But these are more like experimental features that people are trying or things. And here there is a very nice feature which is called facet zoom. So as we saw earlier, facet means to look at one parameter, but I'm going to stop this animation. Yeah. So I'm just going to plot it again. Yeah. So for example, if you see in this part of the plot, the points are too close to each other and you want to have a zoom of this part of the plot. So one way is to just replot it uh, with only this information. And another way is to just add, based on this ggforce library, facet underscore zoom. So how this works is, whatever part of the plot you specify, it's going to zoom into it and add it on the side of the same plot. And this is really, really nice. So we will say that I want to zoom on the x-axis. Right? Let me just see how to write it. Yeah. So on the x-axis, I want to zoom from the date, which is greater than, let's say, 15th of January. So 2020. We just have to write it as the date is specified here. So 1/15, and the date we want to zoom from a date that is greater than 15th of January and less than, let's say, 15th of March or 15th of February. Shruti, so I'm getting you're getting some error. We can look it up later. Yeah. Just we can communicate by email and then see how it works. Yeah, but these packages are having problems with some people, so we'll try to figure it out later. Yeah. So once we do this, yeah, So then you will see it makes a nice plot, your overall data on the top, but then whatever zoom that you have specified, it's going to take that part of the plot and zoom it and make a subplot with only that area that you specified, right? So we specified to make it for x equal to this. So x uh, for x that for which the date was greater than this and date was less than this, but you could keep on doing it for both the axes, it doesn't matter. So we can also say y equal to I think that it would be locked in cases uh, less than 2. Let's see if it works. Yeah. So you can see that it made 2 plots. It's a little bit too big, but what it made was a major plot. Then it expanded the x-axis, and then it also expanded, and then it expanded the x and the y-axis here, right? So on the right-hand side, you see your main plot, and then the expanded one with our parameters. So here we have only the dates from 15th of January to 15th of February, and only the plot from 0 to 2, because we specified that also zoom in on the y-axis less than 2, right? So it allows you to make these kind of zoomed in versions. So it's something that is very helpful. It helps to look at places where you have a lot of crowded data. Yeah, this plot is a bit too crowded, but it's kind of nice, because the thing is that you don't really have to replot your data. You just specify it and it will just make a zoom in. Yeah, so that was it. And I mean, I hope now with this thing you can start plotting your own data and start playing around with ggplot, right? It takes a little bit of time to get used to ggplot because of this layered structure and how to assign things, but once you're familiar with it, it's very powerful and do a lot of things. Yeah. So the next session is on Monday, so a little bit of time, but also the practice session for this time has a lot of exercises. So it's on Swirl, and it's 3 sessions of ggplot. So I think if you go through that, then it will be really easy to get onto ggplot. Yeah. So thank you. Have a nice week and weekend, and then see you on Monday, same time on Monday at 5 p.m. Yeah. Okay. Bye bye.